Good morning. And today, this one's going to be a short video. If you look, we're looking at page 273 of your packet, identifying quadratic relations. Okay, so I'm just going to give you some pointers on how to identify what your conic section is. Okay, if you get something like this one here, that's already in standard form. Hopefully, you recognize you've got a y minus k squared, you've got a x minus h squared, and then one has a plus in front of it, one has a minus. Hopefully you recognize that's a hyperbola opening in the y direction, okay, and that's equal to 1. Now, when you have stuff that's not in that standard form, so maybe this form down here, or this form, or this form, or one of these forms, I'm going to give you some pointers on how to figure out quickly what kind of a conic section it is, okay? So it could be a circle, an ellipse, a hyperbola, or a parabola. This one right here. So what you think about is, if I were to put this in standard form, first of all, it's x squared plus 3y squared equals 9. Hopefully you recognize that's not a circle. A circle would have to be x squared plus y squared equals r squared. But if I wanted to get a 1 over here, divide by 9, divide by 9, divide by 9, I'd get x squared over 9 plus, and this would become y squared over 3 equal to 1. Now notice these numbers at the bottoms are different because I divided everything by 9 and the numbers on the top were different. Okay, so hopefully here you can recognize this is an ellipse. Okay, your x radius is 3, your y radius would be rad 3. So your distance, your x radius and y radius are different, which makes it an ellipse. So let's generalize, okay? The coefficients will be different. Your coefficients of your two squared terms are different. So different coefficients, but you've got the same sign. Okay? You've got a plus in front of here and a plus in front of here. Same signs. Now, if these were both negative, it still might work if there was a negative over here, because when you divide everything out by a -1, you'd get a positive. Okay? If these were both positive and then this is negative, that's not even possible, because a squared term is always positive, added to another squared term always positive, cannot give you a negative. Okay, so that would be no conic section at all. Hopefully you recognize different coefficients, same signs, you get an ellipse. This one, okay, now notice, maybe you recognize off the bat, this is going to be a circle. You could either divide everything by 3 and you'd have x squared plus y squared equals 3, or you could divide everything by 9 if you didn't recognize that yet. You get x squared over 3 plus y squared over 9 is equal to 1. Y squared over 3. 3 over 9 reduced to y squared over 3. So your x radius and your y radius are the same, which makes it a circle. Okay? So you have same coefficients and same signs, and that means it's a circle. Okay? That means if your coefficients are the same, your x and y radius are going to be the same, which makes it a circle. Okay? Now this one looks like you've got same coefficients for x squared and y squared. One's positive, one's negative, but an assumption is that they're all on the same side of the equation. So if you've got 3x squared, bring that to the other side, minus 3y squared is equal to 9. Well, now you've got different signs. Hopefully you recognize here, if we divide everything by 9, okay, you're going to have positive for your x squared, negative for your y squared. And when your x squared and y squared have different signs, that's a hyperbola. Okay, so the hyperbola, you could have the same coefficients, but you could have different coefficients. Okay, I suppose they're always going to be different if one's positive and one's negative. But for hyperbola, you have different signs. Okay, the coefficients themselves, they might be same or different. But as long as they have different signs. Okay, so if we continued and went one step further, we had x squared over 3 minus y squared over 3 equal to 1. So the coefficients are both 1. You might think of those as different. So if they're different, you could cross out this same. But they both have a 1. One's positive, one's negative. So different, the signs count for that, and you know it's a hyperbola. To the next one. Notice this one, you've got x squared. You don't even have a y squared. Okay, so usually when we have something like this, we get that unsquared term by itself. So negative 9y is going to equal negative x squared plus 9. Just moved this x squared over. Divide by negative 9. Okay, and you get y equals 1/9 x squared minus 1. Okay, hopefully you recognize when you get the non-squared term by itself, that's going to be right here. That's in vertex form. You might have to complete the square, but that's a parabola. Okay, so parabola, what you're looking for. This is probably the easiest to identify. There's only one squared term. Either the x is squared and the y is not, or the y is squared and the x is not. So let's go through the rest of these and see if we can follow these patterns and figure out, without doing any work, what kind of conic sections these are. So there's your x squared and your y squared. Okay, those have the same sign, different coefficients. You know right there this is going to be an ellipse. Okay, let me go back and write these answers up here. That was a parabola. This one was a hyperbola. This one was a circle. And this one was an ellipse. Okay, the next one, plus. You have a plus and a plus. Okay, so different coefficients. This has a 1, that has a 4. That's going to be an ellipse. This one, the x is squared, the y is not squared. That's got to be a parabola. This one doesn't really follow a pattern that we identified up above because you don't have an x squared or a y squared, but you might remember this was that one unique type of hyperbola. So this one's a hyperbola. Set of all points where this product x times y is equal to positive 8. And this one, with a y squared and an x squared, one's positive, one's negative. That is a hyperbola. This one, neither of these are squared. So that's just a line. Okay. You have same coefficients, same sign. That is a circle. Okay. Different coefficients, different signs. That would be a hyperbola. Okay. This one, ooh, this is kind of tricky. You've got this plus this equal to 0. It's almost like a circle with the radius of 0. That's a single point. Okay. And then this one, you have a y squared, but your x is not squared. That's going to be a parabola. Okay. Now, one thing, all of these I know are correct, except I want to be a little careful. Let's go check this one, number 5, just to confirm. Okay. Because you've got an x squared plus a y squared, but you have to make sure that on the other side of the equation, when you complete the square, you actually get a positive number. So let's go and check that out. X squared plus 3x. When I complete the square with the x's, I'm going to get plus 3/2 squared, so plus 9/4. Okay, then let's complete the square with the y's. 5y squared minus 4y plus something is equal to, and I'll subtract the 10, negative 10. Okay, so this is going to be x plus 3/2 squared. When we have to complete the square here. When I add that 9/4, I'm going to have to add a 9/4 to the other side. But here I have to factor out that 4 from both. So 5 times y squared minus 4/5 y. And the reason I have to do 4/5, because when this multiplies to this, I just get the negative 4y. And half of this is going to be 2/5. 2/5 squared is 4/25. Negative 10 plus 9/4. When I multiply this together, I'm going to get 20/25. Uh-oh, look at what happens. So what we get here is x plus 3/2 squared plus 5 times y minus 2/5 squared equals, these numbers are not enough to make this negative 10 a positive 10. Okay. So we're going to get, let's get this one we can reduce. We have negative 10 plus 9/4 plus 4/5. Common denominator here is going to be 20. So negative 10 plus 4 times 5, 9 times 5 is 45, plus 5 times 4 is 20, 4 times 4 is 16, so negative 10 plus 61 over 20, wah, wah. This is a negative number, okay? Negative 200 plus 61 gives you negative 139 over 20. That is not possible. To have this thing, which is positive, because anything squared is positive, plus another thing squared is positive, you cannot get a negative. So this one, wah, wah, not on the lips. It's no conic at all. No conic section. Okay, so watch out for that. Okay, and I was watching for that with all these other problems. There were none of these where we had that issue, where we had to check out for that. Okay, hope you enjoyed watching. Thank you for watching. I will see you all soon.